squished together. So this represents a little section, a microscopic section, which shows all the squished stuff being, you know, if the tubules are running in this direction, you cut them off and you're looking at them in this manner. Okay? We have a number of details we can spot here. First of all, the colors are true. Red or pink is PCT. Yellow is DC, is collecting duct, and violet is DCT. Okay, so the colors are true. Green is Bowman's capsule. All right? So the colors are the same as for here. So let's trace things. Here's our afferent arteriole, thicker than the efferent arteriole. Afferent arteriole enters, breaks up into these weird, and you should know 3 or 4 ways in which these are weird, glomerular capillaries. And I told you that the endothelial cells making the wall of these capillaries are fenestrated, and you remember what they keep out, the cells, right? And after the basement membrane, they're covered by these podocytes. These represent the podocytes of the visceral layer of Bowman's capsule. So if I put a piece of tape on here with an arrow pointing at this, at just one of these cells, and I say, identify specifically, you got to tell me podocyte. If I put a piece of tape with several arrows pointing at this in general, I say identify, not identify, identify. Then you have to tell me visceral layer of Bowman's capsule. By now you should know how to interpret my questions. So we have the visceral layer made up of podocytes. We have the capsular space, Bowman's capsular space. Right here, the capsular space. And then we have the outer parietal layer of Bowman's capsule, which isn't made up of podocytes, made up of ordinary epithelial cells. The outer. Okay. So the afferent enters, filter out the water into the space, and then it enters the beginning of this proximal convoluted tubule. Now all these red dots represent the nuclei of the cells, so they're insignificant to us right now. However, the blue lining that you see of all of the PCTs, you see the PCTs all have this blue inner lining? They represent microvilli, which of course increase the surface area, enabling the proximal convoluted tubule to reabsorb as much as 65% of the filtrate. It increases their surface, so you have more surface over which to grab onto molecules and pull them back into the blood. This has often been referred to as a brush border. So it's due to microvilli, but it's called a brush border. Depending upon how I word it, you'll have to tell me which I want. If I don't indicate a difference, then whichever you call it, whether you call it brush border or microvilli, will be acceptable.
Is that the PCT?
No, yes, that's the proximal only the PCT has a brush border. The distal convoluted tubule, as you see, does not have a brush border. So that's how we know to call them by different names, because they're actually constructed differently, they do different functions. Okay? So this one's principal job is reabsorption and also some secretion. But the principal job here is functioning under the influence of ADH to reabsorb water. Most of the other stuff has already been reabsorbed here. Now there's some more stuff that's visible here. And I told you the yellow is the collecting duct, right? Remember I told you about the thin segment? You don't have to worry about this. The thin segment, so you can see it's thinner here, right, of the distal convoluted. So, but anyway, if I ask you, what is this? You should tell me it's a loop of Henle. So this thin thing here is the loop of Henle.
The black stuff?
No, not the black stuff.
The smallest distal.
This is the loop of Henle. Now, some further information that we can get out of this particular model. The distal convoluted tubule, the end of the distal convoluted tubule, comes close to the two arterioles. However, the afferent arteriole, coming close to the distal convoluted tubule, develops these grainy granular cells, shown here in yellow. These grainy granular cells. And the cells of the distal convoluted tubule that come close to those grainy granular cells get packed tight, close together. You see how close together the nuclei are? The cells are tightly packed together. So this is called the macula densa, densely packed cells, okay? Macula densa. And what's this called on your list? Juxtaglomerular apparatus, which I described for you, okay, as secreting. It's known to secrete renin, and it's thought to probably also be the major secretor of erythropoietin, but they don't know that for sure.
You called that on both types of nephrons?
Say that again?
Is it on both nephrons?
No, you don't see it on this model at all. You only see it on this model.
But it's called the same thing on both types of nephrons?
Yes, wherever you have these structures, they're called juxtaglomerular apparatus and macula densa. Anything left out? No, that's everything.